just looking forward to the future, focusing on, we have space station and visiting vehicles, and we still have a lot of work to do.
It's very enjoyable, challenging, and very rewarding, and work with a very good group of people.
I guess about 2 or 3 years ago when it was announced that this was going to be the last shuttle, no one really believed it. They figured that something would come up and we're going to have another shuttle and another shuttle, but I guess all good things have to end at one point.
And liftoff of the Delta II with the NPP satellite, blazing the way at new technology for climate research and weather forecasting.
If you were to go looking for water on the moon, how would you find a good place to start digging? NASA's Lunar Reconnaissance Orbiter has a pretty unique answer. Count the neutrons coming from the moon. LRO's LEND instrument, or Lunar Explorer Neutron Detector, is specifically designed to do just this. But how does counting neutrons help you find water? The answer lies in hydrogen, the smallest atom, and how those neutrons interact with it. So where do those neutrons come from, and what do they do?
Weeks ago, we had another mission over Pine Island Glacier, and when looking out of the window of the aircraft, we noticed a fairly large crack in the ice shelf. And I talked back to colleagues in the US that downloaded satellite images, and they reported that this crack has formed in sometime between end of September or early October. At the moment, the crack is about 80 meters wide. If the crack continues to propagate, it's about an iceberg that has an area of about 800 square kilometers that eventually will break off from the Pine Island Glacier.
So this has implications for the origin of life on Earth. We know that meteorites contain amino acids, which are the building blocks of your proteins, and now from our research, we can show that nucleobases, which are the building blocks of your genetic material, like DNA and RNA, are also found in meteorites. And so these things together could have seeded an early Earth with these really important molecules that could have built up to the larger molecules you see today that are essential for biology.
When we started working on the part, there was a lot that was already in place before we began actually conceptualizing what it would look like. We really had to take a creative approach to come up with the geometry that we needed and try to meet all of our requirements for interfaces and scientific requirements. Right, when they start working on it, they machine it out of a solid block of titanium, and what they do is they use a milling machine and actually mill away slight layers until they get the basic shape.
OSIRIS-REX is the acronym for Origin Spectral Interpretation Resource Identification Security Regolith Explorer. Scheduled for launch in 2016, the mission will collect the first sample from this special type of asteroid that holds clues to the origin of the solar system, and just possibly the kinds of organic molecules that may have planted the seeds of life on Earth. In 2023, the OSIRIS-REX mission will return a sample to Earth, where it will be studied by scientists for generations to come.
MAVEN is the Mars Atmosphere and Volatile Evolution mission. We're trying to understand basically why the climate changed on Mars, why Mars appears to have gone from an environment that was habitable to microorganisms at least, to one that is the cold, dry, uninhabitable environment we see today. By looking at the nature of the upper atmosphere today and how gases can be lost out of the atmosphere to space today, we learn about the processes that control the atmosphere, and we're going to have a good understanding of what the history of the atmosphere has been.
A next-generation space telescope designed to cause yet another giant leap forward in our understanding of the cosmos. It will carry some of the most advanced technologies ever placed on an orbiting observatory.
"18 articulated mirror segments, 2.75 times the diameter of Hubble's primary mirror. Microshutters, waveform sensing and control subsystem, 12 by 18 meter, 5-lane captive-based sunshield."
The Webb Telescope, a revolutionary tool able to study every phase in the history of our universe.
The Webb Telescope.